Welcome to the solutions video for assignment 6.01, assignment number 3. So these are textbook. It's actually all on page 233. Sorry, I don't know why it's decided to zoom. Or not 233, page 33. 233 was the sudden zoom level. And it's numbers 6 to 10. So most of the page, but not all of it. So we have two sets. A is the set of all numbers j such that j equals 2x, where x is between -3 and 6, and it's a member of I, or Z is the actual notation you'll see after high school. B is the set of all numbers k such that k is 3x, from where x goes from -4 to 5, and is a member of the integers, or Z. So we have to A, draw a Venn diagram to show the two sets and determine the union, the intersection, and the number of elements in each union and intersection. So to do this, I'm going to start by actually writing out set A. So we have -6, -4, -2, 0, 2, 4, 6, 8, 10, 12. Set B is going to be from -4 or -12 to 15, counting by threes, because it's -4 times 3, -3 times 3. So -12, -9, -6, -3, 0, 3, 6, 9, 12, and 15. So now we're going to draw our Venn diagram with these two sets. Try to squeeze them in here. I'm going to make some pretty wide ellipses to get them all to fit. And we're only interested in what's in these two sets. So we have -12, -9, -6, -4, -2, -3, 0, 2, 3, 4, 6, 8, 9, 10, 12, 15. For sets A and B. So the union of A and B is anything in both sets. -12, -9, -6, -4, -3, -2, 0, 2, 3, 4, 6, 8, 9, 10, 12, and 15. So the number of elements in A union B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then A intersect B, that's just what's overlapping. That is much easier, and the number of elements in A intersect B is just 4. So that is question 6, parts A and B. Question 7, Rosie asked 25 people at a mystery convention if they like Sherlock Holmes or Hercule Poirot. 4 people did not like either detective. Let's start setting these up. So here we have our Sherlock Holmes circle and our Hercule Poirot circle. We have 25 total. 4 people didn't like either. 16 liked Sherlock Holmes, and 11 liked Hercule Poirot. So this means of the 25, 21 like at least one detective. So that is A union B, where the number of elements in A union B is 21. Number of elements in A is 16. Number of elements in B, if that's our Hercule Poirot, that's 11. So then the number of elements in A union B is number of elements in A plus number of elements in B minus the number of elements in the intersection. So this is 21. These two add up to 27. So we must have 6 in that intersection, which means we have 10 here and 5 here. These do add up to 25, with 21 liking Sherlock Holmes and 11 liking Hercule Poirot. And yes, I would have been one of the 6 had I been in this poll. Number 8. Tashi asked 80 people if they liked vanilla or chocolate ice cream. So if A is for vanilla and B is for chocolate, she asked 80 people. 9 people didn't like either flavor. 20 liked only vanilla, and 11 liked both vanilla and chocolate. So how many people only liked chocolate? This is actually much more straightforward than the rest, because these 4 numbers, the 3 we have and the only number we're missing, have to add up to 80. And the numbers we have add up to 40. So therefore there's 40 left over. Number 9. John asked 26 people at the gym if they liked to ski or swim. So we will label this one with skis and this one, well, let's make it flippers for the swimming. So we have a total of 26. 5 do not like either. We have 19 total who like to ski and 14 total who like to swim. So 21 is 19 plus 14 minus, we'll call it X for the number of overlap in the middle. So we have 21 is 33 minus X, or X is 12. So 12 people like both, which means 7 like to ski but not swim, and 2 like to swim but not ski. So this completes this Venn diagram, and the problem was just to find out how many people like to ski and swim. So technically our problem was done as soon as we hit the 12 before we got to the 7 and the 2. Now, number 10. Tiffany volunteers in elementary classes. She's helping students understand multiples of 2 and 3 in mathematics. The students are working with the numbers 1 to 30. How can Tiffany use a Venn diagram to show the students the multiples that relate to one another? So, assuming it's a good idea for Tiffany to show these elementary students Venn diagrams in the first place, and that they are ready to handle it, we could do it by breaking them down like this. Multiples of 2 in one set, multiples of 3 in the other. So multiples of 6 will be in the overlap, and the rest will be on the outside. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So she could use this diagram to help them connect that there are more multiples of 2 because it's a smaller number than there are of 3, but anything that's a multiple of 2 and 3 can show up on both lists, and some numbers, especially the prime numbers, are going to be on neither list. Notice they're not all prime. Right? 5 times 5 is 25. We just have to go up to 35 before we see the next number that's neither prime and on that list. And obviously 1 is neither prime nor composite, it's just 1. So this concludes the solutions video for homework 6.01, number 3.